Welcome to 2015 question A4. This is a Skew Lines question. So the graphic below shows Derry Peace Bridge, which contains two inclined pylons supported by a cable structure. So we've got these two pylons, and that's what we're looking at here. Okay, they are skew lines. Okay, so as it says here, the two pylons are represented by skew lines A, B, and C, D on the right. So here we have it. So what we want then is to determine the projections of the shortest horizontal line between those two skew lines. So the shortest horizontal line. Okay. So what we're going to do is we want to set up a plane. Okay. And then we can see that plane after as an edge view. So that's what we're trying to achieve. So I'm going to take a level line here from C. Okay, I could take it from A if I wanted. Okay, that would be completely fine. And then I'm going to go parallel here from AB from D. It's parallel to AD from AB, sorry, from D. So parallel to A, D from D. Okay, so likewise I said you could take a parallel line there, or sorry, horizontal line there, or level line, and then you could go parallel to CD from D. Either way it should work. What that has done is it has created this plane. Okay, and this is my level line. Level line. Okay, now I want to find this same plane. I'll just show it parallel. So I want to find this same plane down here in my plan view. So I know that this point here, we'll call it O. It'll be somewhere down in line with itself in plan view. So let's think about it. It's going to be this line here. This is a parallel line to AB. So parallel lines appear parallel in all views. So I'm going to go parallel to AB from D. So same as what we did above, parallel to AB from D. Okay, and that will find point O. And once we found O, we can draw in our level line again. Okay, and the special thing here is that the level line, because it was a horizontal line in elevation, so if I'm looking at a horizontal line in plan, that is going to be a true length line. So this is a true length of level line. Okay, just a little note there for you. Right, now that I have a true length line, I want to look and see that line as a point view. Okay, so in order to see a line as a point view, a true length line as a point view, we need to look along that line. So slide set squares again. I'm going to use an auxiliary. Slide set squares. Here is my x1, y1, and I want to look parallel, look along a true length line, so all those points projected out perpendicular to my x1, y1. Okay, so this is a plan, elevation plan, or projecting from plan, creating an auxiliary elevation. So all my heights will come from my elevation. So I'm going to get the distance from A to my xy line. I'm going to step A off there. I'll get my distance for C. Okay, which is the same distance as O. I can step that off here. And I can get B. B. and D. And there's D. So label those up. So here's my A, B, C, comma, O, and D. And those lines should be parallel to one another. See? Yeah, they are parallel. Okay. So here's my point view of the level line. And because it's point view, any line contained on any line on a plane, if I see that line as a point view, I see the plane as an edge. So I'm seeing an edge view there of CD. Okay, they're looking for the shortest horizontal distance. Okay, so if they were looking for the shortest perpendicular distance, I would look perpendicular to those skew lines that I found. Right, they're looking for the shortest horizontal distance. So this is an auxiliary elevation, my XY line. So if I look at this elevation, my XY line is the horizontal line that represents the horizontal plane. So here's an auxiliary elevation, my XY line is in reality a horizontal line. So I'm going to look perpendicular to that line. Sorry, so sliding set squares. Here's my x2, y2. I'm going to project all of these points. Okay, so here's a plan, auxiliary elevation, auxiliary plan. So it's a plan view I'm creating, and I want to go back 2 views to get my distances from my x1, y1 to my plan view. So get A, let's step off A here, get B, step off B, D, D stepped off, and kind of tricky here because I've gone quite close to x1, y1 with that to see, so still, it's very faint, just mark it up. Okay, so here's my C, A, B, and D. So join those along. Okay, so there are my skew lines again, and what we have here is we have a point view of the shortest distance. Okay, and they want us to determine the projections of that, so we can't just leave that there. We want to project that back along to all of our views. So project back. Okay. Sorry, just a bit of a shadow here from the light. Okay, so on line AB, I'm projecting back onto line AB, and on line CD, project back onto line CD. So that's that projection there. And then finally up into elevation, on line AB, project up to line AB, and on line CD to line CD. And you'll see there we have a horizontal line. Okay, because the shortest horizontal line, okay, I should find a horizontal line here in elevation. That's a good way of checking it. Okay, and same here, here's my x1, y1, it's a horizontal line, so parallel to my x1, y1. Okay, so that is the skew lines. And then part B, determine and indicate in degrees the true angle between the horizontal line and the vertical plane. So our vertical plane in elevation is, we're facing perpendicular to it. Okay, so that line is kind of sloping towards it there in reality. Okay, and we can see that slope towards it. So here's an edge view of my vertical plane. Okay, and here's the line, okay, going towards it. And this is a true length line because it's horizontal here in elevation, so we're looking perpendicular to it. So that's a true length of that distance, or that line. So what we can do is project this line until we hit our vertical plane, and that will find us the angle that's created between them. So project that through. Just maybe highlight it a small bit just to show that projecting through. And then they're asking us to also indicate it in degrees. So we need to measure that angle. I'm actually going to have to extend it so I can see it on my protractor. It's kind of a large protractor. Okay, and that is at 55 degrees. So 55, yeah, 55 degrees. Okay, 55 degrees. Okay, so that is Skew Lines question 2015.